Okay, we are back. We're ready to dive into practice problem number 1. Again, for this one, we're just going to use the z-score formula. We'll get to the probability soon enough. Practice number 1 says calculate the z-score. Part A, they're giving us x equals 40 with a mean of 34 and standard deviation 8. Okay, well, they're giving us x, they're giving us mu, they're giving us sigma. So it's just our job to plug those in, and it'll be as simple as that. So we got our formula. So we're going to say, okay, z equals, x is 40, the mean is mu, standard deviation is sigma, so 40 minus 34 over 8. And grab a calculator and knock that out. You'll end up with z equals 0.75. Now let me explain what we just calculated. What is that? Okay, remember the z-score represents the number of standard deviations from the mean. And we got positive 0.75. So here they told us the mean was 34, right? So if we were to draw a quick bell curve and put 34 right there at the center, then this value 40 is 0.75 standard deviations away. How would we know that? Well, they also told us the standard deviation is 8, right? So there's the mean. If we were to count one standard deviation from 34, counting 8 more, well, we'd be at 42. So 42 would be one standard deviation away. But the x value they gave us was 40. So we didn't make it all the way to 42. We land right there at 40. So it's not even one standard deviation. It turns out, well, we moved 6 units while a standard deviation is 8 units. So the 6 over 8 gives us the 0.75. We moved 0.75 standard deviations to the right. Okay, let's go to part B. In part B, x equals 123 with a mean of 150 and standard deviation 15. Well, to find the z-score, it's as simple as the formula, but I'll give you the explanation as well with a drawing. I can't resist. Okay, so we'll plug in our different parts. X is 123, mu is 150, sigma is 15. So 123 minus 150 over 15 would give us z equals negative 1.8. Okay, big deal. What does that even mean? All right, I mean, I can calculate it, but it'd be nice if I knew what that even represented. Okay, so I've drawn a quick bell curve here with this line underneath. They told us the mean was 150, so that's right there at the center. They told us the standard deviation was 15. Okay, and also notice 123 is less than 150. So if we start counting to the left, 15s, from 150, counting 15 this way would be 135. Counting another 15 would be 120. And we wanted to count 2 because the value they gave us to look at is 123 right there. So how far did we move away from 150? Well, we moved one standard deviation and some extra, and it turns out we moved exactly negative 1.8 standard deviations, the negative meaning we went to the left. Negative 1.8 standard deviations to the left to land at 123. Okay, being able to visualize these things with the graph, crucial for the types of problems we're going to run into in this chapter and in following chapters. All right, let's get to practice number 2. Again, we're just using z-scores here. We'll get to the probability table soon enough. In practice 2, it says test scores follow a normal distribution. Okay, we kind of spoke about that already. A student scored 38 points on a biology test where the class average was 40 with standard deviation 5. Okay. So they scored a little bit less than the average, and the standard deviation was 5. All right. He also scored 76 points on a history test where the class average was 82 with standard deviation 10. So again, he scored a little bit less than the average, but now the standard deviation was twice as much, 10. On which test was the student's performance higher relative to his classmates? Okay, that's interesting. Turns out we can answer this question just by finding the z-scores for both of the tests that he took, one for the biology, one for the history. So here's what we'll do. We'll say, all right, biology versus history. The x value is that student's score. So in biology, he scored 38. In history, it was a 76. That's like the data value. His score is the data value. We also know the averages on the two tests for the class. For biology, mu was 40. For the history, mu was 82. So we scored a little bit less on both. But which one was better relative to his classmates? Well, for that, we need the standard deviations. So sigma equals 5 for the biology, sigma equals 10 for the history, and we're going to find the z-score for both of these. And so you see me kind of laying it out there. So for biology, z equals 38 minus 40 over 5. And for history, 76 minus 82 over 10. And that gives us these z-scores here. For biology, it was negative 0.4. And for history, it was negative 0.6. And with those z-scores alone, we can answer the question, on which test was the student's performance higher relative to the classmates? And what we're looking for is the higher z-score. If the z-score is higher, that means he did better relative to his classmates. And be careful, with them being negative, don't want to mix it up. The biology is the higher z-score, negative 0.4. His biology test was higher relative to his classmates. All right. Let's move along. We'll go to number 3. Okay, now finally we're going to put it all together and find some probabilities. For each of these, each of the parts in practice 3, they are telling us the z-score or z-scores as they come later, and it will be our job to look them up in the table. Okay, here's what I recommend. I don't recommend that you have to refer to this lecture every time, this document, every time you want to use the table. We're going to be using these tables a lot. I highly recommend that you print the Z tables and just have them with you while you're doing homework, while you're listening to lecture for the next few chapters, while you're taking your test. You want to have those. I'll provide them on tests as well digitally. But you really want to, it'd be so much easier if you just had them printed out, a lot easier to work with that way. I've got mine here printed out. By the way, you can find these, if you look on the internet, you can find Z tables, and they look just the same as mine here. So there's no difference there. And, I printed back to back because I had printed this at the school, when we were still in session or when we were still meeting on campus. So if you can, I really recommend you print these. I've always printed them for my classes in the past, but obviously that's not an option now. Okay. Anyway, so I'm going to be referencing this. You can reference the digital or print if you can do that. Okay. So let's get to part A. Determine the probability using Z tables. So part A is the probability that capital Z is less than 1.32. Okay, so you notice the similarity to the continuous random variables that we did in chapter 5. Although now we don't use capital X, we use capital Z because, well, it's all about z-scores. So the probability that capital Z is less than 1.32. Okay, so what we're going to do, we're just going to grab our table. And we're going to look up the z-score 1.32, and that's going to answer this question because, remember, the table always finds the probability less than the number you look up, and that's exactly what this is asking, z less than 1.32. Okay, so here on the first page in the document, or the first page here. These are all the negative z-scores, starting on the far left and then moving towards 0. So there's 0 at the very bottom. But we have a positive z-score here, so I'm going to flip this over. And it picks it up at 0 and then goes all the way to positive 3.4. Okay, so looking up 1.32. So I'm looking down. Okay, there's 1.3. And then that would be 1.30, 1.31. There it is right there, 1.32. And hopefully you can read that. That's 0.9066. That is our answer. And there's no work to do. There's no formula. You just use the table. 0.9066. And we like 4 decimal places here. Just copy that whole thing. Okay, let's move to part B. The probability that z is less than negative 0.78. Again, we have a less than. So this is really nice. We don't have to do anything special. We're just going to look that number up in our z-table. This one, though, is negative. So I don't want my positive z-scores. I'm going to flip this on over. Go to my negative z-scores. Negative 0.78. Okay, well, they get closer to 0 as I go down. So I'll look up negative 0.7, negative 0.7, and I'll try and get it on the screen. Negative 0.78. I would have to go all the way. The very last one is 9, so this one right here is negative 0.78. That is 0.2177. So there's our answer, 0.2177. And you notice these answers, they're representing probabilities, right? So in the first one, the probability that your z-score is less than 1.32, 90.66%. Probability that your z-score is less than 1.32. The probability that your z-score is less than negative 0.78, 21.77%, or 0.2177. Important not to forget what these represent. They're probabilities, the likelihood of those things happening. Okay, let's go to part C. What's different about part C? Okay, part C, we've got a greater than. So remember how we approached a greater than for the continuous random variable. How did we approach a greater than? Because we can only find probabilities less than. And if you remember, for a greater than, you take a complement. So here we go. The probability that z is greater than 0.55, we do it as 1 minus the probability that z is less than 0.55. And I've got some notes just kind of explaining what's going on there. Let me get to those notes in a minute. Let's look this up. Let's answer the question first. Where is 0.55? Well, I need the positive side. Okay, and so there's 0.5, 0.55, 0, 1, 2, 3, 4, and 5 is right here. 0.55 is 0.7088. And so I need 1 minus 0.7088 for my complement. And if I do that, I barely squeezed it in down here, 0.2912 would be the answer here. Okay, now let's talk about my graph and my drawing there. Let me kind of try and zoom down a little bit. What did we do? Okay. If we're saying z is greater than 0.55, we're thinking, what is the area above? So if I was to draw a quick bell curve, remember it's z equals 0 there at the center. So z equals 0.55 would be a little bit to the right. And we want to know the probability greater than. So what is that probability right there? What is that area? Well, what we do instead is do 1 minus all the probability below. So that complement, that's the area below 0.55. So doing the 1 minus, and it's got all the same logic as any of the other continuous random variable problems and why we do the complement here. Okay. Good to reiterate though. All right, let's go to part D. Here we've got a between. The probability that z is between 0 and 0.55. Or 0 is less than z is less than 0.55. Well, how do we approach a between problem for a continuous random variable? Well, we have to do two different calculations and then subtract them. So to find the probability that z is between 0 and 0.55, we take the probability that z is less than the larger 0.55 and subtract the probability that z is less than the smaller, and that will find the area between them. Okay, well, we already looked up 0.55 just a moment ago. We found it to be 0.7088, so we already have that number. Let's look up the 0, and for this one, we could use the positive or the negative side of the table. They would give the same thing. 0.00 is exactly 0.5. And that makes sense because 0.00 is right at the middle, and how much would be less than? Well, 50% of the data, right, is on the left, 50% is on the right, but what it's measuring is that probability on the left, 0.5 exactly. So we can find 0.7088 minus 0.5000, and there's our answer right there, 0.2088, and I couldn't resist, I made a little drawing there. So if we just want the area or the probability between 0 and 0.55, well, there it is. So we found all this area and subtracted all that, leaving behind just this. Okay, finally, part E. We've got another between, but some other numbers now. So the probability that negative 2.70 is less than z is less than 1.64. We're going to take the same approach. Negative 2.70 less than z less than 1.64. We'll find the probability that z is less than the bigger one, 1.64. Subtract the probability that z is less than the smaller one, negative 2.70. And we'll get our answer this way. Okay, well, we'll have to look both of these up. 1.64, I'll go to my positive z-scores. There's 1.60, 1, 2, 3, 4, 0.9495. And the other z-score was negative 2.70, so I need the other side here. Negative 2.70, 0.0035 is that probability. So plugging those in, 0.9495 minus 0.0035, subtract, and we got our answer, 0.9460. All right. So, just reflecting on that one, I don't think I made a drawing there. Very high probability that you would be between these two z-scores, no matter what the context, whether it be test scores or heights or who knows what, blanking. But we'll see. We'll see a lot of examples coming up. You also notice, maybe you saw it already. Look at the probability for negative 2.70. Like, that doesn't seem like that extreme of a z-score, right? Okay, you're 2.70 standard deviations to the left. But look at the probability of that happening. 0.003, not even a percent make it to negative 2.7 z-score. And look at the probability of being under 1.64. Almost 95% of the data is below 1.64. That doesn't seem like a very big z-score, right? But that captures almost 95% of all the data. The idea is this bell curve, it drops off very fast as far as counting standard deviations goes anyway. Okay, let's stop this video here, and we will continue with some more difficult ones in the next.